Hey everyone, and welcome back to the channel. Think about why companies want to move away from their on-premise data warehouses. The biggest reason is usually scaling. Those old systems just get too difficult and expensive to grow as your data explodes. The goal is to build a modern system that's not only secure and scalable but also cost-effective in the long run. But let's be super clear, migrating a big, complex, deeply integrated data warehouse from your own data center to BigQuery is not a simple, flip-a-switch kind of job. You've got to be really careful. You don't want to break all the systems that rely on your data, your reports, your analytics dashboards, your machine learning models, just because the data looks a little different during or after the move. So, you absolutely have to plan this migration carefully. So, what does a typical, successful data warehouse migration strategy look like? It usually involves a few key stages. Assessment and planning. This is where you do your homework. You need to understand exactly what you have in your old data warehouse, what data is where, how different applications access it. Migration. This is when you start building your cloud foundation on GCP and actually begin moving the data. As you set up the cloud environment, it's smart to do small, focused proofs of concept, POCs, to make sure your data migration processes actually work and to get a sense of the timelines. Validation and testing. This stage is all about making sure the data that lands in BigQuery is exactly right. You need tools for automated, intelligent data validation, checking both the structure, schema, and the actual data itself. Often those applications change. Now, let's quickly look at an example of what this migration architecture might look like on GCP, as shown in this diagram. You start by setting up the foundational elements, IAM for security, resource hierarchy, billing, networking, and pipelines for automating deployments using tools like Cloud Build and Terraform. You connect your on-premise data centers to GCP using things like Cloud DNS and Interconnect. Before you load real data, you turn on monitoring and security services like Cloud Operations and Security Command Center to make sure everything is visible and secure. Then, you extract data files from your old on-premise EDW and move them to cloud storage. You set up continuous synchronization using tools like BigQuery Transfer Service to keep the data flowing. From cloud storage, you might use Dataflow to process and transform the data before loading it into different layers in BigQuery, like staging, core, and information layers. You use automated tools, perhaps running in a GKE cluster, that's Google Kubernetes Engine, to validate the data that's been moved and transformed, comparing it to your source. You might use Cloud SQL for auditing purposes or historical data synchronization. Application teams test against these validated datasets throughout the process. Cloud Composer, which is managed Apache Airflow, is used to orchestrate this entire complex pipeline, coordinating all the steps from extraction to validation. It can even integrate with your existing on-premise scheduling tools. Throughout this, you maintain close communication with the teams providing data into the EDW and the teams using data from it, for reporting, analytics, etc. You set up fine-grained access controls in BigQuery using IAM so that different user groups only see the data they're supposed to. You connect existing reporting and visualization tools like Tableau or custom applications to BigQuery. And as you bring more workloads onto BigQuery, you can incrementally adjust your processing capacity, maybe using BigQuery's flat rate pricing, to manage costs effectively during the transition. Thanks for watching, and I'll see you in the next one.